Okay, graphing inequalities must be in point slope form. So I wrote that on the board here. Now in this box is going to be a different type of inequality. So let's go over the inequalities and we can go over graphing. So this first inequality is called less than. And you are going to be dotted. In addition, we're also going to have a shading below for this inequality. The one on the side is going to be greater than. It's also going to be dotted. It's now going to be shading above. Next we have less than or greater than. So this less than or equal to here is going to be solid. Same with the greater than or equal. It's also going to be solid. The less than or equal is just going to be shading below. And the greater than or equal to is going to be shading above. The biggest trick of the trade is that the line underneath the inequality, if you have it, it's a solid line. If you don't have it, it's going to be dotted. Okay, so let's get to the problem. Alright, so the vocabulary you need to worry about for this section is feasible region, which means it's something possible in a given region. So if you have a graph, and for example the lines intersect at these three places, this is called the feasible region. Okay, in this example we have y is greater than or equal to 2x plus 7. 2 is our slope. 7 is my y-intercept. This is a greater than or equal to, so we know we're going to shade above. And it's going to be a solid line. So, looking at my y-intercept, I'm going to go to my y-axis and plot a dot. My slope means I'm going to go up to the right one, down to left one, keep with that process. Here's the graph. Since we're shading above, it looks like so. And we're done. Here's another example. We have y is less than or equal to 5x plus 20. 5 is our slope. 20 is my y-intercept. And we know we're going to shade below. And have a solid line. Because we have less than or equal to. So I'm going to go up to my y-intercept, plot is 20, and I'm going to go down 5 to the right one. Keep with that process. Looks like this. And we're going to shade below. Okay, on this problem we have y is less than negative 5x plus 35. This inequality states we need to shade below. And it needs to be dotted, since it does not have the line underneath. So our slope is negative 5, and we have a positive 35 y-intercept. So I'm going to go on my y-axis, plot on 35, and now I'm going to go down 5 to the right. Keep going in that process. I have a dotted line. And I'm now going to shade blue. Okay, so this one's an interesting one. It is not in a y format, it is not x. So we're still going to create our x and y axis. I'm going to focus on my x values. Now when you see an x equals form, that is always going to be a vertical line. So we're going to have a vertical line. You know it's going to be a vertical line because of the x. We know it's a greater than. We know we're going to shade above. And we know that it's going to be dotted. So I'm going to make a vertical line on 8 with a dotted. Put my arrows in. Now, obviously there is no up or down because we have a vertical line. So when I mean shading above, we're going to look at the number line. So on the right, numbers are bigger, so we're going to shade on the right. Okay, now here we have the opposite. We have y-intercept, but we don't have a slope, and we have y. So when this happens, we're going to have a horizontal line. We know that we are going to shade blue, and it's going to be solid. So in our graph, we're going to make an x and y equals chart. We're going to worry about our y values. So 2, 4, 6, 8. Where we have negatives. So we're going to say this is about -7. And make a horizontal line. That's a solid line right here. Let's make this a little bit easier to see, so I'm going to raise this up a little bit. And since we're shading below, we're just going to look like this.
Hey.
Okay, in this example, we're going to graph the inequalities and label the feasible region. So recall that the feasible region is the select area that anything can work. So I color-coded each example. So we have y is greater than or equal to 2, x is less than or equal to 8, and y is less than or equal to 2 plus 1/2 x. So we're going to do each of them individually. So the first one we're going to do is y is greater than or equal to 2. So since y is greater than or equal to 2, we're going to make a horizontal line on 2. It's going to be solid because we have a line underneath. And this states we're going to shade above. So using orange, I'm going to shade above. Now doing this example on your notes, I would suggest you use a highlighter or a different color pencil so you can see the effect here. Okay, so now we're going to do the next one, which is x or less than or equal to 8. So if it's horizontal for y, we're going to have a vertical for x. So I'm going to make a vertical line, which is also solid because of that line underneath. And it says less than, so that means I'm going to shade to the left. Alright, so as you can see, the orange and the green are starting to overlap, and that's what's going to happen because what happens is all of these three equations are going to overlap in one area, and that's going to be our feasible region. So lastly, we have this example. We have y is less than or equal to 2 plus 1/2 x. So let's go back. 2 is our y-intercept, so I'm going to go on that 2 right here, and I'm going to go up 1 to the right 2, and I'm going to keep going. We know it's a positive slope. We know it's solid. And we know we're shading below. Okay, so reviewing with the y equals right here, we have this area. and the y greater than or equal to 8, we have this area. And the y less than or equal to 2, we have this area. So, if you look, this area right here is our feasible region. So any of these points can work. So when we look in there, we can see that, let me get a different color. This region right here, let's do this. Let's make it a bigger print. This is our feasible region. Any of those points inside that triangle works. So if this was a word problem, you can say 3, let's do an easy point. So we can say 3 meaning 4. That works. 3, 4 is in the feasible region. Another one would be 5, 6. That's another point. Anything here wouldn't work. So when I ask you to give me points in the feasible region, it's just to see which one's inside. Okay? Now these corners do not work because this does not hit all the equations.